Finishing off this unit on electronic sensors, we should look at some output devices. Now this could just be a light bulb or a speaker or something like that, but we're going to look at a couple of quite specific examples. First off, a pair of light emitting diodes, with them set up in parallel like this, but you see how they're opposing one another. So that means only one will ever light up. If the output is positive, the electricity will flow from top to bottom, so the green LED will light. If the output is negative, the electricity will flow from bottom to top, since the earth line is now more positive, so the red LED will light up. Now these are going to be great as indicators with either a red or green light coming on depending on the input to the op-amp. If we put some kind of potential divider on the input, perhaps with a thermistor in there, we have made an electronic sensor that can tell us if the oven is still hot or if it's okay. We're going to need a couple of resistors in here though to protect the LEDs from damage. The current only wants to be about 20 milliamps to get the light we want. So let's say the op-amp will saturate at 12 volts and the LED needs 2 volts to operate. What should the resistance of the resistor be? Take a moment to work that out. Okay, hit pause. The total PD is 12 volts. The LED will take 2 of those, so the PD across the resistor should be 10 volts. The current should be 20 milliamps, which makes the resistance 10 over 0.02 equals 500 ohms. The second output device we're going to look at is a relay. This is simply an electromagnet attached to the output of the op-amp. When there is a negative output, the diode here blocks the current. When there is a positive output, the electromagnet creates a magnetic field that closes the switch in the second circuit. That's all simple IGCSE material. For A level, what is going to happen when the op-amp output goes back to negative? Have a good long think about that. There's an op-amp providing a current through a coil, which has a magnetic field. Then the current stops. What happens next? All right, pause. Don't come back too soon. Because what will happen is the magnetic field will disappear. Then what? That's the key to this question. Have you thought about what will happen when the magnetic field disappears? This means we have a changing magnetic field. So that is going to induce an EMF across the coil that opposes the change creating it. This happens quickly and there's a lot of energy stored. So the EMF that's going to be created is easily large enough to damage the op-amp. We need to protect it, and we can do that by putting another diode in the circuit to protect the op-amp. When the top of the relay coil is positive, a magnetic field was created. Removing the field means the bottom of the coil will become more positive than the top, and this diode allows any current to safely run through it and the coil, so the energy will dissipate. Another popular output device is simply attaching it to a voltmeter and calibrating it to let us record the temperature or whatever the sensor components are detecting. I'll leave you to look into that some more and hopefully try building some. We've looked at the whole of the electronic sensor now, really, from the input, the sensor components, to the processor, to the output devices. And hopefully this has given you a taste of electronics and you're going to want to go on and learn more about it.